Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session I will share with you how you can use Raspberry Pi 4 RAM with the latest bookworm 64-bit operating system, and you can create object counter on custom object. We will detect here a cabbage. We have our video, we have basically the drone footage video, and then I will explain how you can use Raspberry Pi 4 for creating the counter. So counting cabbage with Raspberry Pi plus Yolo. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today I will share with you again new project where we will use the Raspberry Pi, the latest operating system bookworm 64-bit version, and I have already created the model which will detect the cabbages. I have used a RoboFlow ready to use dataset. Then I have created the model using Yolo, and then I have converted the model into .tflite format, which is the lightweight model for working on the Raspberry Pi, because the Raspberry Pi is a lightweight device and we have here Raspberry Pi with the 4 GB RAM. So I need to convert the model for .tflite format. So I have converted the model into .tflite. I have shared the model inside project folder. So I will mention the link. You have to simply purchase the project folder and then you will get all the files and folders. So let's just start it. As you can see, this is what the project. So I will mention the link, as I mentioned, inside description box. So now I have already downloaded the project folder inside downloads. So this is what the project folder, as you can see, in zip format. Right click, just click on extract here. It will extract our zip folder as a normal folder. So right click again, just cut it, go to the file manager, and then the paste folder over here, go inside the folder. And because this is completely fresh installation of latest bookworm, so we need to run some certain commands first. So imp.txt file, as you can see, the imp.txt, right click, open with text editor, and then first we want to run the first command. So just copy as it is, open the terminal, and then paste the first command inside our terminal. As you can see, let me make like this way. So this is the first command, sudo rm usr libpython 3.11. so I have mentioned the command and then just hit enter. It will remove the external, manage all these things. Then we need here latest Tony Python IDE. So for that we want to upgrade the Tony Python IDE. So second command, pip3 install -- upgrade Tony, just paste it, second command inside terminal as it is, and then just hit enter. It will upgrade the Tony Python IDE. So friends, we have upgraded our Tony Python IDE. Now let's just minimize all these things, minimize. So we have done with upgrading Tony Python IDE. So minimize the terminal and we will go here in menu, click on it, programming Tony Python IDE. Just open Tony Python IDE. So this is completely fresh version. So we want to first change the Tony Python IDE with switch to regular mode. So just click on switch to regular mode, click on OK. Now just close it, Tony Python IDE, again go to the menu, programming, and Tony. It will open the Tony Python IDE, as you can see. Now this is what our regular mode. So as I mentioned, we will use here Ultralytics Yolo. So we need packages. Go to the tools, manage packages, and first package, which is opencv-python, hit enter. It will search for opencv-python first package, then click on install button. It will install opencv-python on our bookworm 64-bit version. So we install opencv-python, then the next package, which is Ultralytics for Yolo, Ultralytics, hit enter, first package, click on install. Now it will install Ultralytics. So friends, we install Ultralytics package successfully. Now because as I mentioned, we will use here our Ultralytics model into .tflite format. So for that we need TensorFlow. So TensorFlow, and just click on search on PyPy, or you can simply hit enter. First package TensorFlow, the main package, click on install and it will install TensorFlow. Now let's just wait. So friends, we have done with TensorFlow installation also. We successfully installed TensorFlow. Now we need a CVZone package. So search for CVZone, first package. Again click on install. It will install CVZone. So we have done with package installation processes. We install all the packages. One more thing friends, as you can see right now I am accessing Raspberry Pi Book 1 operating system inside Windows machine using the real VNC. So if you don't know how to access Raspberry Pi GUI, the graphic display in Windows machine using real VNC, I have already created a video. I will mention the link of that video inside this particular video. Watch the video and access Raspberry Pi in Windows machine using real VLC. Simple. So we have done with package installation. Now friends, what we will do, we will simply open our code. So just open project folder. Inside that, as you can see, this is what the model, which is .tflite format, which I have created using RoboFlow dataset. I have trained over the 1000 images using RoboFlow dataset, and then I have converted the .pt model into .tflite format for Raspberry Pi. And then this is what our video file. So let me open vid.mp4 first. So as you can see friends, this is basically the video file. So let me play again. So this is the video file. As you can see, we have cabbages here. This is the drone footage. So our goal is to detect cabbages, also create a counter. So we will open main.py with the help of Sony Python IDE. So I have opened the main.py with the help of Sony Python IDE. As you can see, the model base.pt, but we have to mention our tflite format model. So just open project folder. This is what our tflite format model. Right click, rename, and we have to copy the name of the model. So copy it, cancel, close, and remove the base.pt model like this way. Remove it. Ctrl+V, paste it, the model, the .tflite format model. Then vid.mp4, which is our video file. And then if you scroll down, so here as you can see, I have mentioned the frame resize, and because right now friends, we are using the .tflite model, so we have to mention here, because there is no classes, so classes is equal to 0, just remove it, the classes is equal to 0, and here we will mention imgsz, the image size is equal to 240, because we are use here a .tflite format with image size 240, and just save it. Okay, so then just scroll down, and inside this model we have two classes. Basically, one is cabbage center and one is cabbage. So I have used only the cabbage because I want to detect whole cabbage. So I have mentioned if there is a cabbage, means if we detect the cabbage class, then we will have the rectangle color, we will have the circle, means the center point of the object. So center point object is basically the cx and cy, x1 plus x2 divided by 2, y1 plus y2 divided by 2. This is how we will get the center point. And then because we have our model, so it will of course detect the cabbage. Now what I will do, I will simply run the code. Here I have mentioned 0, cv2.wait key is 0, because I want to freeze the frame. When I have explained the code, I will start while loop. So let's just run the code first. If there is any error, we will solve the error. So friends, as you can see, there is no error. We are detecting here cabbages, As you can see, we are detecting the cabbage. This is the cabbage, the rectangle, green color rectangle with the text name. Okay, so because right now I am skipping the frame manually, so when the cabbage detected, there will be a count 1. When the cabbage detected, there will be a count 1, then count 2, and when the cabbage center point touch the line, as you can see, the rectangle color will be changed. The rectangle color will be changed. Okay, rectangle color will be changed. So now let me stop the code first, and then what we will do, we will simply mention here, let's just say, if we want to, because this is what the Raspberry Pi, we can simply resize the frame. So right now I have mentioned here 1020/600. So let's just say, if I go with 600 is the width and 480 is the height of the frame. Okay, and if I run the code, so friends, now as you can see, we change the frame. Now frame size is basically 600 is the width and 480 is basically the height. Okay, so now for our knowing purpose, I have mentioned here like the cabbage, their rectangle and their center point. But let's just say, now we know that we have cabbage, so we can only detect the cabbage when the cabbage center point touch the line. So here as you can see, after name I have mentioned cu2.rectangle and the class name. So we can simply comment these two lines. So now only when the cabbage center point touch to the line, then only it will show the rectangle and all other things. So as you can see, right now there is a green color rectangle. Let me check here. If I stop code and if I go at the end, so friends, here it is. As you can see, when we have cabbage class, again I have mentioned here a rectangle and circle method. So this method also we want to comment it. Okay, now let's just save the code. If I run the code, and now as you can see, on the frame there is nothing. There is no rectangle, there is nothing. But let's just say, if I skip the frame, and here it is. As you can see, this cabbage center point touch the line, there is a red color rectangle, there is a track ID, and we increase the counter. Means right now only when the cabbage center point touch to the line, then we have the red color rectangle, their class name, and there is ID. Let's just skip the frame one by one. As you can see, this cabbage detected, we increase the counter. That's it. So we are perfectly detecting our object. We have track ID. The tracker we use basically from the Ultralytics by default tracker. Okay, so here inside our object detection, as you can see, there is a ID, there is a IDS. From Ultralytics we have ID, means each cabbage we have unique ID. So when we detect the object, there will be a unique track ID. Done. Now we are detecting the object, we are tracking the object. So now the next thing, creating the counter. So let me start again the code. So we have started the code, and this is what our frame. So for drawing the line, simply if you move your mouse cursor on the frame, inside shell you will get the coordinates. The current position of the cursor. So if I move my cursor over here, you will get the current position, current points xy coordinate of the cursor, and the current points is basically 2 and 89. So 2 and 89, so 89 is basically the y coordinate. 89 is basically the y coordinate. So I have to mention here, line y is equal to 88. So then line y is equal to 88. So if I want to draw the line on the frame, simply I will use here cv2 dot line method. As you can see, cv2 dot line method, cv2 dot line method. So the line xy coordinate is basically, as you can see, the 0 0 0 is basically x and 89 is basically y. So line y we mention as a 88. So 0 is x, the start point of the line, and line y we mention as a variable. So line y is equal to basically 88, and then this is what the end side of the line. This is what the start point, and this is what the end point. So end point x coordinate is basically frame dot shape. Frame dot shape is basically the frame width and height. So let's just say if I print here, if I print frame dot shape, if I print here a frame dot shape, if I save the code, if I run the code. So friends, we started our frame and we are printing here frame dot shape. So as I mentioned, frame dot shape is basically the height and the width, or let's just say width and the height. So 480 is basically height. 480 is basically height of the frame, and 600 is basically width. So if I want to draw the line, so line start point is basically 0 and the line y, xy coordinate, and the line end point is basically the frame dot shape, and frame dot shape is, now we need here the second coordinate, So this is the 0 which is the height, this is the width which is the first. So 0 1. So I want this 600, so I will mention frame dot shape 1. 1 is basically this index number which is the width of the frame. So frame dot shape is basically now x coordinate which is the 600, and the y coordinate which we want to mention same as a start point of y coordinate. That's why I have mentioned here line y. This is how we draw here, this is how on the frame we draw the line. That's it. So we have now our line. Now what we want, we draw the line using cv2.event mouse move function. Now we want to create the counter. For creating counter, as I mentioned, we will use here the track ID. So track ID, so for that we want to create a dictionary, and inside that dictionary we will save the track ID along with their current position. So cabbage current position is basically their center point. So hist, as you can see, hist, so I have created here hist as a dictionary. So inside that dictionary we are saving their current position and their track ID. Each cabbage unique track ID with their current position. Now we are saving inside our dictionary. So now inside our dictionary we have our current position and we have the track ID for each cabbage. So we can create the condition. If the track ID inside our his dictionary, then we can simply get the previous point of cabbage. So previous cx and previous cy is equal to hist, and inside that we will pass the track ID. This is how we will get the previous cx and previous cy. Now we will create the condition. If the previous cy, because we want to use here a line y, so from center point, the previous center point and the current center point, we will use the y. So previous cy, if it is greater than the line y, greater than is equal to cy, then we will increase the counter. So we mention here a count is equal to 0. Then when our condition match, we will increase the counter. counter, and then we will draw the rectangle, circle, we will put the text name, and then we will put the track ID. That's it. This is how the counter will increase. And because we want to show the counter on the frame, so we will use here cvzone.putTextRect method along with the frame top left corner, which is the 50/30, and the color of the rectangle box. So as you can see, count 0. Now let's just start while loop. So for starting while loop, we want to remove 0, just mention 1, click on save and run the code. Now it will start while loop. It will automatically increase the counter. So friends, as you can see, it is increasing the counter. Our video is moving. When cabbage center point touch the line, we are increasing the counter. It means our project is perfectly working. So this is how, friends, with the help of Raspberry Pi Bookworm 64-bit version, you can detect custom object. Also you can create your own counter. I have mentioned the project folder inside description box. Simply purchase it. We'll meet our next video. Till then, thank you, take care, and bye bye.